G'day YouTube, welcome back to the VK8FOS YouTube channel. You can see here in my browser, we're going to be talking about LTE decoding again. LTE is 4th generation cellular, and it's basically the most common communication protocol used for the communication of mobile cellular devices such as smartwatches, smartphones, and then you've also got embedded LTE devices that might be in like vending machines or those little payment terminals, you know, where you just like tap your cards. A lot of those have an LTE SIM card and modem inside. So it's a very, very widely used protocol in the world. Countries such as Australia have already turned off 2G all the way back in like 2016, I believe. And then just last year, to a lot of controversy, we turned off 3G. And that sort of turned out to be a very controversial thing here in Australia, because a lot of people suddenly couldn't make emergency calls because they hadn't upgraded to a LTE device yet. So yeah, you can look up all the controversy surrounding that in your own time. Now, if you go to this on my channel, you'll see that I've got this playlist here. It's not really that, it's not jam-packed with videos in the LTE department. But what I do have there is pretty interesting. So as you can see here, I've already got 2 videos regarding LTESniffer, and we're going to be talking about LTESniffer again. So I think it was this video specifically, or both of these videos. I used to get a lot of comments saying, "Dude, can you please do a tutorial on this?" So this is it. This is the big tutorial. It's going to be sort of a 2-part tutorial because I'm going to actually show you guys how to find LTE cells as well, not just decode them. We're going to use a tool called lte-cell-search. I can't remember what it is. Hang on, what is it called again? lte-cell-scanner, that's the one. And I'm going to show you guys how to install that, and then we're actually going to search for LTE cells to decode, and then we're going to use LTESniffer in the second act to actually decode those, to decode that cell. So I'll just get started. I've got my video recording beer here because it is 2 p.m. in the afternoon, so I'm going to have a sip and then I'll get on to explaining the hardware requirements for you guys. Okay, so the first thing we're going to need is a software-defined radio. In a nutshell, software-defined radios are a computer-attached peripheral, typically via USB, and I think some of the higher-end cards are actually like Ethernet, and some are actually like PCI card slots. PCI cards that slot into your PCIe bus on your computer. You need a expensive SDR for this. I'm sorry, there's no other way to get around this. The Blade RF is very, very expensive, okay? But it's the cheapest way to get going with LTESniffer. So I'm using the XA4. The XA9 should also work, and then I think there was during the chip shortage, I believe there was an XA5, but they're rare, very rare, and only sold for a short amount of time during the chip shortage a few years ago. Yeah, unfortunately, there's no way to get around this. You're going to have an expensive SDR, and I think you need a USB 3 interface because LTE sends data at a rate of like 1,000 frames per second, so that is a lot of data. I just don't think that USB 2 could handle that kind of throughput. So yeah, it works with the LimeSDR 2 perfectly fine. At the end of this video, I might even demonstrate that, but just for now, all intents and purposes, we're going to be using the Blade RF. Now you're going to need an antenna, okay? Those little tiny we call them rubber duck antennas in Australia. They're okay for like short range experiments, but if you want to target cells from a wide area, you're going to need a base station antenna. And base station antennas are typically mounted outside, on top of a high structure such as a roof or a radio tower. I'm actually using this one here. It is 1.7 meters long, so it's really, really large. And you can see here the frequencies here. It covers basically all cellular frequencies, all in a single antenna. It's really, really good antenna. I don't think they make these anymore. I got it off Facebook Marketplace for like $20, brand new. It was a really, really good purchase. So I'm using that. It's actually got 10 meters of coaxial cable already, so if you do mount it outside, you've got enough feed line to reach into your software-defined radio. And I think that's all we really need for the hardware. So I'll talk about software now. Of course, you guys knew it already. We're using DragonOS FocalX, and that is my favorite Linux distribution for software-defined radio. People say, oh, dude, you should use Kali and all these other like InfoSec and pen testing Linux distributions, but I'm not a pen tester. I don't do TCP IP stuff. I do software-defined radio and RF stuff, so that's why I use DragonOS. So if you guys aren't using this, I just have to ask you why. And it's made by a good friend of the channel, Aaron, from the SEMA Executor YouTube channel. The second thing we're going to need is a application called lte-cell-scanner. Now, I've actually patched this because the original lte-cell-scanner didn't work with the Blade RF. So normally to search for LTE cells, you had to unplug your antenna from the Blade RF and put it in either a RTL SDR or a hack RF. And that was getting really annoying because my Radio Shack is outside and I do everything remotely from like in the nice air-conditioned studio here. So I've patched it. When I say patched, I commented out a bunch of lines and it actually works with the Blade RF 2. It only worked with Blade RF 1 before. So I've done that. I'm not taking any credit for this software. I didn't make it. All I did was patch it. So thanks to the author for this awesome piece of software. I'll show you guys how to install that later. We're just going through the requirements now. And then we've also got LTESniffer, which is pre-installed already in DragonOS FocalX, so we don't need to do anything with that. We also need Wireshark and Tshark as well. They're already included in DragonOS. And that's all the things we need, so that's really cool. Alright, let's get started with the practical segment now. Now I'm going to minimize my browser. And then if you haven't done so already, we need to open up a terminal window. Now, I have done, so we're going to show, I'm going to show you how to search and scan for LTE cells now. So you guys are going to have to go to my fork of lte-cell-scanner and then scroll down to read the README file, right? So like everything, we always revert to the meme. Always read the README file before you send me emails saying this isn't working. Now, this will probably only work in DragonOS FocalX. If you're using another Linux distribution, go for it and go and try it. But I can't provide support because I don't use any other Linux distribution. Sorry. So yeah, we're just going to basically follow the. We're just going to follow the instructions in my. In the README file here. So I'm going to make sure I'm CD'd into my home directory. I'm going to copy. Oh, sorry, we need to. Oh, hang on. Okay, that's better. All right, so we're just going to copy these commands one by one. And that's cloning the Git into my home folder here. And you can see that that's appeared just here. So that's good. We're going to CD into the directory. We're going to make a directory. So that's makedir, which is make directory. We're going to call it build. We're going to CD into that build directory. And then we need to run the cmake command listed in the README file. Press enter on that. And then now we're going to actually build the application now. So that's going to, this command here will query your PC to find out how many cores it's got. And then it's just going to run, like, for example, this computer's got 4 hyper-threaded cores. So it's just going to return that this computer has 8 cores, and then it's going to run 8 worker threads when it's building this. It'll just speed it up a little bit. Okay, so that completed very quickly now, so that's good. And then, yeah, we can just follow the README file for instructions on how to actually run this. So I know for a fact that there is a LTE cell operating on 763 megahertz here. So I'm just going to copy the command directly out of my README file. And then we're going to hit enter on that. Sometimes it takes a little while with the Blade RF compared to the Hack RF. There we go. So it's found, we can see detected the following cells. And we have a frequency division FDD cell operating on a frequency of 763 megahertz, and the power is quite strong. So don't forget, like when we're talking about like receive signal strength, numbers closer to 0 are better. So if it's like -9, that's stronger than -12. I know it doesn't make much sense and it's kind of counterintuitive, but closer to 0 is better. So yeah, that's quite strong. So we have a cell that's very, very near my location. So I highly recommend, if you scroll down here, I highly recommend that if you read this paragraph here, it's actually, I don't recommend searching for, like, scanning a range of frequencies for a LTE cell. It's very slow with the Blade RF. RTL-SDR and Hack RF, it's super quick, but with the Blade RF, it's super slow. So I recommend using your spectrum regulator's website to find LTE cells around you. So in Australia, we have the ACMA database here, and we can actually do a search for something called an emission designator. So every classification of an RF signal has a emission designator, and then that's just got information about, like, is it analog or is it digital? What's the bandwidth of it, and etc. Right? So every RF signal is classified with an emission designator. So here in Australia, one of the LTE network operators uses this emission designator here. Right, so I can go to the ACMA's website. I can write in this thing. I can write in that. So there's different emission designators for different carriers, but this particular carrier uses this one. So, and I can go to return to map, and then it just shows me like all the cells. So all these little green dots here are all LTE cells, and that's how I found the frequency of 763. So I'd much rather do this as opposed to actually searching a gigahertz for, or something like that, or searching a few hundred megahertz for an LTE cell, because it will take probably days or weeks to do it with a Hack RF. So, with a Blade RF. So yeah, that's pretty cool. So if you guys want to actually install this, right, we scroll down to this section here. So if you just run these two commands, it'll actually overwrite the lte-cell-scanner that's already pre-installed in DragonOS. And you might not want to do that because you do have a you do have a Hack RF or an RTL. So actually, there we go. Sorry, I had to refresh because I did actually make an addition to the README. So we can actually copy this command here, and then that will copy the cell search binary, change its name to cell search -blade RF, and then copy it to our user local bin directory. So we can actually, so if I just run that command, I should be able to now write cell search -blade RF, and then let's just send it the H argument. And then there we go. So I can actually CD back to my home directory and then run that command anywhere now without having to CD into lte-cell-scanner. So after you've done that, it's perfectly fine to delete this file now if you want to, but I'm just going to leave it there because as you can see, I don't have a cluttered home directory. So I'll just leave it there for now. And then, you know, like everything, you can delete it later if everything's working just fine. So that's pretty cool. So there we go. That's how we do that, guys. That's how you actually search for and make sure that there is an LTE cell operating on a particular frequency. So that's pretty cool. So before we use LTESniffer, we actually have to configure Wireshark, okay? It's very fiddly to do this, so you guys are just going to have to follow along with me. So if you go to the LTESniffer GitHub, there's actually this readme.md file inside PCAP file example. So we have to follow the instructions on this to configure Wireshark to be able to show us data from the LTE cell. So if you do not do this step, you'll run LTESniffer and then you'll get a PCAP file with decoded packets from the cell, but you won't see anything because we haven't configured Wireshark, okay? So this is going to be interesting because there's a lot of stuff to do here. So I'm just going to move my browser over here. And then I'm just going to basically just follow the instructions here. And then hopefully that will clear up any questions that you guys have about this process. So I'm going to just follow the instructions here. So we go to Edit, Preferences. Now we go to Protocols. I think we have to collapse the tree, and then we go to DLT user, which should be down here somewhere. DLT user, got it. Okay, we go to edit, and then we need to transcribe all these values here into here. So this is the part that's quite time consuming. So we have user 0, and then we have to, yep, so that's 147. So we have to write Mac -LTE -framed. Then we add a second user, and we go user 1, and then we write NAS EPS. So we add user 2, which should just be UDP, and we add user 3, which will be S1AP. Okay, and then we just hit enter on that, and then we'll just go edit again to make sure that the values have been saved, and they have been, which is great. So we'll click OK. Oh, let's scroll down. And let's just OK this window now. And then I believe we have to go to Analyzer, or Analyze, Enabled Protocols. And then we search for LTE. So we just write LTE in the search bar there. Hope you guys can see this, sorry. Okay, so we tick Mac LTE UDP. We tick PDCP LTE_UDP. We tick RLC_LTE UDP. And I believe that's all we do. And then we press OK with that. And then, okay, cool. I think we're all configured. So I'm just going to probably close Wireshark now, just so the settings get written, I guess. I don't know. So I'm just going to close Wireshark there. And that is everything we need to do. So we can actually get to the actual LTESniffer portion of the tutorial now. So we don't need our browser window anymore. So we need 2 terminals for this, right? So one terminal is going to run the LTESniffer command, and then the bottom window is going to run either Tshark or Wireshark and show us the packets coming in real time. So yeah. Okay, so when you run LTESniffer, it creates a bunch of files, right? And it kind of clogs up your home directory. So what I'm going to do is I'm going to make a working directory called LTESniffer. I'm going to cd into LTESniffer. And then in our file browser, we'll see that this file just got created, and then I'm going to enter it. And lo and behold, this is the command you need to run. So this command here has been tailored for me because I'm using a Blade RF. I'm actually using a low noise amplifier on the Blade RF, so I don't want too much gain. You guys could probably use 30 or 40 for this value if you're not using an LNA. If you are using an LNA, 10 has been perfectly fine for me. And I've got 8 cores on this computer, well, 4 hyper-threaded cores, so that's 8 threads. So W stands for worker threads. I've got 8. The rest of this, you guys could just leave that alone. Don't touch that. And obviously the frequency is unique to my situation. So I'm just going to hit enter on that command. And we can see a bunch of files just get created inside the LTESniffer directory. And as you can see here, we have a PCAP file and it is growing in size rapidly. Remember I told you guys before that LTE transmits data at an extremely high rate. This PCAP file, if you leave it unattended, will go to 2, 3, 4, 5 gigabytes in less than an hour, typically, I've noticed, or sometimes. Depends how much traffic is going on the cell. So that's cool. We have stage 1 of our decoding setup working. Now, the second command we're going to do, because we're super cool hackers, we just do everything in the terminal window. We don't really like doing GUI stuff, us cool hackers. No, I'm just kidding. I'm not a hacker. I'm just an RF enthusiast. I like GUIs too. I'm going to hit enter on this command here. Now, this is a tail command, which means tail will dynamically reload the PCAP file as the data is being written to it. So we can actually see the packets coming in real time, which is really cool. And then all this other stuff is just related to Wireshark, so don't touch that. And I'm going to hit enter on that. Oh no, embarrassing. I didn't CD into LTESniffer folder. Oh well. Okay, put that command there back again, and then hit enter on that. Oh, silly me. It's only half a command, that's why. That's better. There we go. So that is very reminiscent of how 2G is decoded, you know. You have like all these like system information blocks and security mode command. That's your ciphering mode command from 2G. So it just goes to show that there is actually a lot of 2G and 3G actually at the core of LTE, you know, like all these cellular generations are just like improvements on the last one. So there is actually a lot of stuff that remind you of 2G in there. There's even some stuff about CDMA in there, which is like CDMA is like 3G, you know, so it's pretty cool to analyze this traffic. So yeah, that's how you do that. Now I have to reiterate that there's no private data in here, right? LTE uses encryption. I think it's called the EPS1 or something like that. It's like yeah, it's like some EPS encryption algorithm or something, EEA1. So there's no private user data here. This is all just public data used for the management and control of an LTE cell. So that's pretty cool. So I'm going to quit Tshark now. And we're going to do it the GUI way. So this, for people newcomers to Linux, the GUI is always the way to go. The command's very similar. I'll put all the commands for you guys to copy and paste into the description below, so don't forget that, and the pinned comment as well. And yeah, I'm just going to hit enter on that. Put this over here, and there we have it. LTE packets flowing freely in our Wireshark window, so that's pretty cool. So yeah, that's about all I've got for this video. What I might do is I actually don't have a plan for it, but I'm just going to actually pause the video and get set up with the LimeSDR Mini 2.0, and then I'm just going to demonstrate the capability for that to actually successfully be used with LTESniffer. So I'm just going to pause the video, get set up, and I'll see you guys very shortly. Okay guys, I'm back. And as you can see here in the top terminal window, you can see that I now have my LimeSDR Mini attached now, and that's connected to my cellular antenna. So yeah, let's clear this terminal. And I've got another command here to run. I've just tailored it specifically for the... I haven't even tried this yet. This is off script, so I've just tailored this command again. I've changed a few things. I've increased the gain because I don't have a LNA on board, low noise amplifier. And I've changed the driver to Lime, which I think is how you address a LimeSDR in with, what is it, GR Osmo SDR or SOAPy SDR. So yeah, let's hit enter on that command. And let's see what happens. Outstanding, just like that. It works perfectly. It's actually not in the documentation about the LimeSDR working with working with LTESniffer. So that's really, really cool. Let's run the... Let's not get too excited with the GUI, but let's just run the... Oops. Let's just run the Tshark command, and let's just view the decoded packets again. There you go. LimeSDR works perfectly fine. LimeSDR 2, sorry, should I say. It's very specific to 2. I've never tried the first one, so... Yeah, obviously you get what is it, RTNIs or RNTIs or whatever. They're like supposed to replace an IMSI. It's like a temporary IMSI, so you can't track cellular mobile users or whatever. So I'm going to have to... You might notice like a lot of blanking out going on in the post-production of this video. That's perfectly normal because I can't show that information. So anyway, I hope this video went a little bit too long. Sorry about that. I always like to just do my videos as, you know, a couple of bros shooting the shit kind of thing, you know, hanging out with you guys. So apologies for that. I'll put some timestamps and things of that nature there so you can just get straight stuck into it and you don't have to listen to me ramble on. Yeah, I hope you enjoyed the video. Thanks very much for watching. Bye.